All right, let's get right into it. If you want to understand cybersecurity, really understand it, how things get attacked, and more importantly, how we defend them, you've got to start at square one. You have to know how the internet actually works. Because if you don't get the blueprint, you'll never understand how it breaks. This right here, this is the foundation.
Think about that for a second. You type a website into your browser, hit enter, and bam, it just appears. It feels like magic, right? But what's really going on under the hood? Well, today we're going to follow the journey of a single website request. We're going to demystify that whole process. Because hidden inside that seemingly simple trip are all the secrets to understanding online threats.
So here's our roadmap for the journey. We're going to start with the big picture, the network itself. Then we'll zoom in on how computers find each other with the internet's address book. After that, we'll look at how your data actually makes the trip, how we keep that trip private, and finally, where it all ends up and who's guarding the door. Let's do this.
First up, what even is the internet? I know it sounds like a basic question, but before we get into the nitty-gritty, we all need to be on the same page about what we're actually talking about.
At its absolute core, that's all the internet is. Just a whole bunch of computers connected together all around the world so they can talk to each other. And that postal system analogy is pretty much perfect. When you request a website, your little bit of data gets packaged up, sent through this incredibly complex system of routes, and delivered to the right spot, just like a letter.
Okay, so if the internet is a giant postal system, then it needs the one thing every postal system can't live without. Addresses, right? You can't just send a letter to my buddy Steve. You need a street, a city, a zip code. The internet is exactly the same. Every single device that's connected to the internet, your phone, your laptop, your smart TV, and yeah, the server that's hosting your favorite website, it has a unique IP address. Think of it as its digital home address. It's the only way data knows exactly where it's supposed to go. Without it, everything would just be, well, lost.
Now, here's something wild. We actually started to run out of these addresses. The original system, which we call IPv4, was designed way back when the internet was tiny. Nobody ever dreamed we'd have billions and billions of devices online, so they came up with a new, much longer format called IPv6 that basically guarantees we won't run out of addresses again anytime soon. So we've got these number-based addresses, but wait a minute. You and I don't type a string of numbers into our browser, right? We type names like google.com. So how does that work? Well, that's where the DNS comes in. It is literally the phone book of the internet. Its one job is to look up the name you type and find the matching IP address number that computers actually understand. And this whole thing happens in a flash. You type the name, your computer calls up the DNS phone book, asks for the number, the phone book gives it back, and your computer immediately connects to it. It's so fast, so efficient, you never even notice it's happening. But here's the scary part. What if someone could poison that phone book? What if they could change an entry? That is exactly what DNS spoofing is. An attacker tricks the system so when you type in, say, your bank's website, it sends you to a fake one that looks identical. You type in your password, and boom, you just handed it over. This is a huge deal in cybersecurity. Okay, so we've got an address. We know where we're going. Now, let's talk about the letter itself. How does your request actually get from your computer all the way to a server on the other side of the world? I love this analogy because it perfectly explains the idea of packets. See, your data doesn't travel as one giant file. Instead, it gets chopped up into thousands of tiny little pieces called packets. Each packet is like one page of that book, sent off on its own journey. They might even take different routes, and then they're all reassembled in the right order at the destination. Now, this method is super efficient for sending a lot of data, but it also creates a major vulnerability. If those little pages aren't protected, an attacker can sit on the network and just sniff them as they fly by, reading what's inside. It's kind of like your mailman reading all your postcards before they get to you. So this brings us to a really important question. If our data can be read while it's traveling, how do we make it unreadable? We need a way to secure the conversation. And that brings us to the two languages our browsers speak. You've definitely seen these at the beginning of a web address. HTTP is the basic one. Think of it like sending that postcard. Everything is just written in plain text for anyone to see. But HTTPS, and that S is the important part, it stands for secure. That's different. It encrypts the data. It's like putting your letter in a locked box with a key.
Even if someone grabs it, all they see is scrambled, unreadable gibberish. And this is exactly why you should never, ever enter sensitive info on a site that only uses HTTP. An attacker can literally place themselves in the middle of your connection to the website and just read everything. Passwords, credit cards, you name it. That little padlock icon you see on your browser, that's your best friend online. Always look for it.
So we've covered the address and the journey. For our final act, let's talk about the destination. Where is all this data actually going, and what's standing guard when it gets there?
This is pretty much the fundamental model of the whole web. Your device, your phone or laptop, is the client. It asks for stuff. The big, powerful computer that stores all the website's files and data, that's the server. It serves you what you asked for. And because these servers hold so much valuable data for millions of people, you can bet they are massive targets for hackers. So to protect those servers, one of the most important first lines of defense is something called a firewall. Just think of it like a digital security guard standing at the front door of the network. It inspects every single piece of data trying to get in or out, and based on a strict set of rules, it decides whether to let it pass or block it. It is an absolutely essential piece of the security puzzle.
So let's do a super quick recap of our journey. IP addresses are the unique home for every device online. The DNS is the phone book that turns names into those addresses. Your data travels in tiny little pieces called packets. HTTPS is the secret code that encrypts your conversation. And firewalls are the security guards protecting the destination. So there it is, the basic blueprint of how the internet works. You now know the core parts, how they fit together, and the fundamental threats tied to each one. And that leads me to one last big question for you to think about. Now that you understand the blueprint, where do you think the real cracks in the foundation are? Is it in the technology itself? Or is it maybe somewhere else?